Hello everyone, I am Jitin Shonkar. My classification machine learning project on coronavirus tweet scientific analysis. My group members are Rishi Gupta, Shumana, Jitin, myself, Ankit, Mang. So start with the problem statement. The COVID-19 pandemic has taken a very foundation of society wherein people were forced to live inside their houses because of the lockdown being imposed and also the livelihood of the almost every section of society was impacted. The objective of our analysis revolved around the knowing the sentiment of people from their tweet on the Twitter, as the Twitter is one of the prime means of expression over social media. So our approach is text pre-processing, exploratory data analysis, feature engineering, and pre-processing and model training. So different algorithms use logistic regression with great search CV, decision tree classifier, KNN, SVM classifier, multinomial bias, Bernoulli naive bias, random forest, and stochastic gradient descent. Here we use two techniques, counter vector and TF-ID vectorization, which convert text form into a numerical form, which is useful for a modeling. So here's a GitHub link and start with a problem statement. This challenge asks you to build a classification model to predict the sentiment of COVID-19 tweet. The tweet has been pulled from a Twitter and the manual tagging has been done there. The names and the usernames has been given the code to avoid any privacy concern. We are given the following information: location, tweet at, original tweet, sentiment, username, and the screen name. Here are the general guidelines. First, we start with the gathering and the labeling the data, with the pre-processing our data and different text representation, then modeling and evaluation, and the last process is deployment. So let us start with know your data. So first start with the import libraries. Here different libraries are NumPy, Pandas, Matplotlib, Seaborn, WordCloud, and different model libraries like import, trend test split, logistic regression, decision classifier, grid search CV, KNN, and here the confusion matrix and classification import and import cross validation score. That is a grid search CV. So here we start with a load data set. Load data set from the Google Drive, and here the first view of our data set by using a tweet dot head, username, screen name, location, tweet, original tweet, and sentiment. Here is a data set row and column count. Here is a tweet dot shape used for shaping. Shaping here there are 41,157 rows and 6 columns, and the column names are username, screen name, location, tweet, original tweet, sentiment. Here tweet dot index start with a starting value with 0 and stop value with 41,157. The step and the step value is 1. Here tweet dot info. Here username has 41,157, similar to all location, but in the location column, here 32,567. There are no duplicate values here by tweet dot duplicated, and they here to check the missing the null values. Here only location have a null value, that is 8,590, and here so what do you know about data set? In this data set, we find that there are 6 columns having location, username, screen name, tweet at, original tweet, sentiment, and location. Column have duplicate value, that is 8590, which can take action later or proceed on classification machine learning project. So start with the understanding of variable. So here again, the tweet base start with a column, username, screen, location, tweeted, original tweet. Here, tweet dot describe having a different function like count, unique, top, frequency, mean, standard meridian, mean, 25% and 55% and 75%, and maximum is used. So here the variable description. Username, this column contain the username of the person who posted the tweet. Screen name, this column contain the screen name or handle of the user who posted the tweet. Location, this column contain the location of the user who posted the tweet. This could be their city, state, country, or any other geographical location that have been specified in their Twitter profile. Tweet at, this column contain the date and the time when the tweet was posted. Original tweet, this column contains the actual text of the tweet that was posted. Sentiment, this column contains the sentiment assigned to the tweet. This level could be positive, negative, extremely negative, neutral, depending on the sentiment analysis algorithm used for the classify the tweet. Let's start with the data visualization. The first visualization code is count the number of occurrence of each sentiment within the sentiment column. Here, the positive sentiment having a highest number of count, that is 11,422, and the lowest is extremely negative, is 5,481. So now we consider that positive equals to extremely positive and negative sentiment equals to extremely negative. So now we left only with a positive, negative, and neutral. In this bar graph, we saw that the positive sentiment have the highest and the lowest is extremely negative. So now we left with only the positive, negative, and neutral. In this pie chart, we saw that 43.85% have the proportion of sentiment, have the positive, have the highest number of sentiment, and the negative sentiment 37.14%, and neutral having 18.74%. In the third visualization code, we find the top 10 most frequently occurring location from the location column. That the top location of tute is London and the lowest is Australia. So in this bar graph, we saw that London having the highest number of tute and Australia have lowest number of tute. In the fourth code, we find the calculate the length of number of character of each tute and store the result in the text length column. So top tute length having original tute row having a row number 25,160 having a 355 character, and the lowest having a 9,776 row number having only 11 characters. Now in this bar graph, we saw that 25,160 is a 355 tute character count and 9,776 having a 11 characters only. In this, we can count the number of tute for each unique date in the tute column. Here, the 20 March 2020 having highest number of tute, that is 3,448, and the lowest is 28 March 2020 having a lowest, that is 23. So in this bar graph, so that the highest number of tute at 20 March 2022. So start with the feature engineering and data preprocessing. We first find the handling the missing value. We find that location having only a null value, that is 8,590. In for modeling, we can't take any location column, so we can't remove any location or fill the null values. So how to handle handling an outlier? So we do not handle the outliers because we did not take any column having a continuous data, numerical data as a dependent and independent column during the model. So start with the textual data processing. Here the analytical library. This is library for handling the textual data. So in the original tute column, we apply the analytical library. So first we lower casing, then remove punctuation, remove URL, remove stop word, remove white spaces, refresh text, tokenization, and normalizing text. That is the stemming and lemmatization. So first we remove URL, then tokenize text into word, then remove non-alphanumeric character, then remove stop words and punctuation, then lemmatizing the word. So here clean tute save with a clean tute column name from the original tute. If we apply tute.head, then separate clean tute column name with a proper sentencing. If we create an array of list, then apply lambda function with a tute temp list. Here the import counter library used to count a particular of words coming in a particular column. So here the corona message is maximum time coming, that is 18,045, and the one is coming 2093 times. So similarly, we apply for the different sentiment column for neutral, positive, and negative. We can separate the different tutes from the original tute column, that is from positive, negative, and that is neutral. Here we form a bar chart with the highest number of coronavirus, that is 18,045, and the lowest is 1 in the top 30 words. Here import word cloud to forming clouds of word in the different column of sentiment, that is negative, positive, and neutral. This cloud word come from neutral word, that is rebel, buy, let, stay home, festive, Russia, and so on. Similarly, in the positive sentiment, coronavirus, Australia, advice, phone, and stop, and so on. And similarly, in the negative also, the outbreak, COVID-19, stop, ready, prevention. These are the words come from the negative sentiments. So start with the features manipulation and selection. First, start with the data splitting. We assign the independent variable tude as a clue tude and dependent variable the sentiment. So applying the train test displays by X test, Y train, and Y test by splitting the test size of 0.2, random state equals to 10. Why data splitting ratio have you used and why? Data splitting ratio is 80% used for training data set and 20% used for test data. By providing more data for training, the model can learn more patterns and train the data, which can lead to better prediction on a new unseen data. Checking the save of the splitted data by print xtrain.save. Here, 32,995 are used for the training data set and 8,232 are used for the test data. Data scaling. This method you use to scale and why. Here no need of any scaling of data set because here only check sentiment of people and we analyze only user sentiment according to the scenario of COVID-19. Handling the imbalanced data set. There is no handling of imbalanced data set because we use only original tude and sentiment column for a modeling. So no, here we decided that we use only two column for machine learning model, that is original tude and the sentiment, and in both the column equal number of, that is. Now start with the ML model implementation. What is count vectorization? Count vectorization is a process of converting a piece of text into a numerical format that can be used by the machine learning algorithm. In this process, the text is first split into words or token. Then each token is counted to create a vector of numbers representing the frequency of each word in the text. Here, we import the vectorization from the scikit-learn and then bag of words by the n-gram content, that is the unigram, that is 1 comma 2, to get the shape of the numpy array between the x train and the x train. Here the x train is 32,925 rows and 19,312 columns, and the x test is 8,232 rows and 19,312 are columns. So model one with backup words, ML model one, logistic regression. What is logistic regression? Logistic regression is statistical model that probability of event taking place by having the odds again winning the range between 0 and 1 or multi-classification for the event be linear combination of one or more independent variables. So first we initialize the logistic regression model, then define the dictionary of parameter to T over, that is L1 and L2, that is last one and regression of penalty to apply L1 and L2. Here C is the inverse of regression strength, and here the grid search CV is 15. So the our accuracy comes 0.79% at 79%. And here the classification report of different metrics, that is precision, recall, F1 score. Here we more focus on the accuracy, then focus on the precision, then focus on the recall, and later on F1 score. So here the confusion metric. Here the diagonal matrix represented the true positive value. So explain the ML model used and it performs the using evolution matrix chart. Here the algorithm use logistic regression with accuracy of 79% and different evolution metrics which are with the levels of negative, neutral, positive like precision. Recall F1 score is also increased. Which hyperparameter optimization technique have used and why? Gray search is used to tune two hyperparameter for logistic regression model. The regularization penalty L1 and L2 and the inverse regularization instance C. The performance of the model is evaluated using cross-validation with the CV parameter set to 15. Have you seen any improvement? Note down the improvement with the update evolution matrix chart. Yes, I've seen the evolution matrix chart. Accuracy is 79%, precision is 77%, recall is 77%, F1 score is 77%. So ML model 2. Decision tree classifier with CV. What is decision tree? Decision tree is a flowchart like a structure when each internal node represents a test or attribute, that is a feature. Each branch represents the outcome of the test and each leaf node represents of a class level or a numerical value in the case of regression. Here first in the slide with a decision tree model, then fit the model, then predict the model. So the accuracy comes with 70% and the classification report of different precision, recall, and F1 score. Here the confusion matrix of the decision tree with a diagonal true positive values. So explain the ML model and use in performance using its evolution matrix score chart. Here the algorithm distribute accuracy with 70% and different evolution matrix score chart with levels of negative, neutral, positive like precision, F1 score is also increased. Which hyperparameter optimization technique have you used and why? Scikit-learn library is used to perform a class validation based on the decision tree with a model of 5-fold. The np.mean function is then used to calculate the average accuracy across all the folds. Have you any seen improvement? Yes, I've seen the improvement in the matrix chart as follows. Accuracy 71%, precision 71%, recall 70%, F1 score 71%. So ML model 3. What is knife vibes? Knife vibe is a probabilistic machine learning algorithm used for a classification problem. It is based on the Bayes theorem, which describes the probability of hypothesis that is the class level given some evidence that is the input feature. In the knife vibe, the assumption is made where that the features are conditionally independent given the class level, which means that the presence or absence of one feature does not affect the probability of another feature. So here we use two types of library, that is Gaussian and the multinomial and the Bernoulli library. And so here we only need to apply both types of knife, that is the MNB and BNB, that is the multinomial bias and the Bernoulli knife. What is multinomial bias? Multinomial bias used for the discrete data where the feature represent count of frequencies of occurrences. So here fit the multinomial naive classifier with MNB, the bag of word, and use the trained predictor by classifier to predict the level and compute the accuracy of the predicted level. So here the accuracy come with the 68%, and here the classification report that the precision, recall, and F1 score. And here the confusion matrix with the diagonal values are with the true positive values. So explain the ML model and performance. So in the multinomial web, the accuracy comes with 68%, and yes, there's an improvement. There's accuracy of 68%, precision 68%, recall 69%, F1 score having with a 68%. Bernoulli knife vibes. Bernoulli knife vibes are a variant of multinomial vibe used for a binary or multi-class data where the features represent the presence or absence of a particular attribute. For example, word in a document. So here same procedure with a multinomial vibe. Fit a multinomial vibe classifier with ambit bag of word. Use the trait classifier to predict the label. Compute the accuracy. Here the accuracy come better with a multinomial that is 69%. And here the classification report is precision. I recall F1 score for the different sentiment, that is negative, neutral, and positive. So the confusion matrix with the diagonal matrices are two positive values. Explain the ML model. In the code provided, the Bernoulli knife we use the classified data resulting accuracy of 69%. Yes, here the improvement is C. The accuracy of 69%, precision of 68%, recall of 70%, F1 score have a 68%. Here the KNN, the model 4 is KNN, the K nearest neighbor. It is a simple algorithm that works the finding the K closest instances of the training data set to give an input instance and then assign the level of majority class among those instances as a predicted level for the input instance. So first initialize the KNN classifier, then define the hyperparameter training, then the grid search with 5-fold cross validation, fit the KNN model to training data, and then print the best hyperparameter and mean cross validation score. Here the best parameter for Ni would equals to 1 and the mean cross validation is 0. Here accuracy with a 39%. There is a classification report on performance metric of different negative sentiment, positive sentiment, and neutral sentiment of the precision, recall, and F1 score. So here is a confusion matrix, that is diagonal matrix represented as two positive values. Explain the ML model and use it performs using a evolution matrix score chart. KNN here performed a worst accuracy of 39% for different evolution metrics such as precision, recall, and F1 score for each level of negative, neutral, and positive. Here hyperparameter for Ni board is defined as the from ranging values of integer to 1 to 9, and grid search is used then to evaluate the performance of KNN algorithm with each value of Ni board with a 5-fold cross validation. Yes, there is improvement in the evolution matrix and there is accuracy of 38%, precision is 53%, recall is 47%, F1 score is 40%. Here, the model ML model 5, the support vector machine. It is a supervised learning algorithm that works by finding the hyperplane that best separated the classes in the input data. In the multi-class classification problem, multiple hyperplanes are used to separate the classes. The optimal hyperplane is one that maximizes the margin, which is distance between the hyperplane and the closest point of each class, known as the support vectors. So first we initialize with SVM, then fit the model, then the predict the model. Here the accuracy is 76%, and the classification report on a performance matrix is neutral, positive, and negative for of precision, recall, and fun score. Here is a confusion matrix with a diagonal matrix of different different values of represented true positive values. Support vector machine algorithm classify resulting in accuracy of 76%. Yes, have been the improvement in the accuracy with 75%, precision 77%, recall 77%, upon 77%. So the ML model 6, random forest. Random forest work on by constructing the multiple decision tree on a randomly sampled subset on a training data set. Each tree is trained on a different subset of the features and the data, which help to reduce the overfitting and improve the generalization performance. During the prediction, the input instance is passed through the each decision tree, and the majority vote among the prediction of the individual tree is taken as a final prediction. So import from a random forest is scikit-learn library, then the fit the classifier, then predict the level of test data set, calculate the accuracy of the classifier and the test data set. Here accuracy is with the 76%, and the classification matrix report of different sentiment, that is negative, neutral, and positive of the precision, recall, and F1 score. Here is a confusion matrix. A random forest algorithm used to classify the data resulting accuracy of 70%. Hyperparameter technique has been used with random forest classifier. The classifier has been initiated with hyperparameter of n estimator equals to 100 and random is equals to 42, which default value in the absence of expletive hyperparameter tuning. No, here there is no evolution matrix score chart improvement. Accuracy is 75%, precision is 75%, recall with 75%, F1 score with 75%. So the ML model, that is this is last model, that is stochastic gradient descent. What is the stochastic gradient descent? In SGD, instead of computing the gradient over the entire training set, the gradient is computed on the randomly selected subset or the mini batch of the training data set. This reduces the computational cost of algorithm and enables faster convergence. The model parameters are updated after each mini batch, and the process is repeated until the convergence or a maximum number of iterations reached. SDG can work well for a large data set and high dimension data set. It can efficiently handle large amount of data and converge faster traditional gradient descent. Here the accuracy of stochastic gradient descent is 80%, which is the best in above algorithm model. And here the classification report on a different performance matrix also increases the negative, neutral, and positive at 82%, 70%, and 84%. Similarly, in the recall, 80%, 72%, 85%. In the F1 is 81%, 71%, and 84%. Here is the confusion matrix chart. So another technique, TF-ID vectorization, term frequency, inverse document frequency. TF-ID is calculated as the product of two value, term frequency and the inverse document frequency. The term frequency measures how frequently a term appears in a document. The inverse document frequency, IDF, measures how important term in the entire corpus, by parallelizing the term that appear in many documents. As before in the backward, also apply data splitting. Here also splitting is done. First, we define the independent variable and the dependent variable. So independent variable is clean fit and the dependent variable is sentiment. So applying the test and split, that is X test, Y test, and Y test. Here the test size equals to 0.2, that is 80% of data used for the training data set and 20% used for the test data set. So 32,925 rows are used for a training data set and 8,232 are used for the test data. Import count vectorizer and TF-ID vectorizer from the scikit-learn. So here the TF-ID vectorizer using the unigram concept, that is range from 1, 2, and here TB extend say. that is 32,925 rows and 19,312 are columns. So start with the model logistic regression. As similarly in the backward, the similar algo used here for the TF-ID vectorization also. So here is L1 and L2 for a hyperparameters tuning, that is L1 and L2, that is C equals to, and the C equals to inverse regularization 100, 10, 1.0, 0.1, and 0.1. Here the accuracy come with the 78%, and for the TF-ID vectorization, logistic regression is the best performing model. So classification report on performance metric for a different negative, neutral, and positive sentiment for a precision recall F1 score. So here the confusion matrix, the diagonal matrix represented the two positive values. So logistic regression was used to classify the data, resulting accuracy of 78%. Which hyperparameter technique used? The hyperparameter space defines the parameter dictionary which specifies the value of regularization parameter C and the parental term L1 and L2. Grade search we also have to prevent the overfitting and ensure the model generalizes as well to unseen data. Here there is an improvement in the evolution matrix chart. Here the accuracy is 78%, precision is 79%, recall is 79%, F1 score is 79%. So decision tree. To first initialize the decision tree classifier, then fit the model, then predict the model, then accuracy with a 62%, then classification report on performance metric for the different sentiment, negative, neutral, and positive. So here is a confusion matrix of a diagonal value presented two values, two positive values. Explain the ML model and performance using the evolution matrix so chart. Decision tree algorithm was used to classify data resulting in accuracy of 62%. Here, there is no any improvement in the evolution matrix chart. So accuracy with the 62%, precision with 60%, recall with the 60%, F1 score with naive. There are two types naive, Gaussian naive and multinomial naive used for TF-ID vectorization here. So multinomial naive with accuracy of 69%, and here a classification report on a different sentiment of negative, neutral, and positive. Here is a confusion matrix with a diagonal matrix presented two positive value. So here the accuracy is 65%, precision is 68% and 66%, and F1 score is 2%. So here the improvement shown. But similarly, in the Bernoulli naive, there are 69% accuracy, and here is a classification report for different sentiment, that is negative, neutral, and positive. So here's a confusion matrix chart. Here accuracy with 69%, precision with 68%, recall with 70%, and F1 score with 68%. So another model KNN, K nearest neighbor. So first initializing model, then hyperparameter tuning with N neighbor, then the read search CV, then fit the model, fit the data to model, then accuracy here it come with 27%. So in the count vectorization and TF-ID vectorization, KNN performance worst case, worst algorithm for both count vectorization and TF-ID vectorization. So confusion matrix here, here the accuracy is 27% and the precision 62% and recall is 40% and F1 is 25%. So there is no improvement in the evolution matrix score chart. So random forest. To first import a random forest classifier on the scikit-learn, fit the classifier training data set. Here the hyperparameter thing is n estimator equals to 100 and random is equals to 42. Predict the level for test data set. Calculate the accuracy for classifier on test data set. Here the accuracy is 73%. A classification report of performance matrix of different sentiment, that is negative, neutral, and positive. Here a confusion matrix chart with the diagonal matrix represented two positive values. And here the accuracy with 72%, precision with 73%, recall with 73%, and F1 score with 73%. Yes, there is an improvement in the evaluation matrix chart as shown. Stochastic gradient descent. So first import SG classifier from scikit-learn to initialize the SGG classifier object with a desired hyperparameter, train the model of the training data, predict the level for test data, calculate accuracy of a classifier on test data, classifier report of performance matrix of different sentiment, that is negative, neutral, and positive. Here a confusion matrix chart, and here the accuracy with the 72%, precision with 77%, recall with 77%, and F1 score is 76%. Here in the yes in the scene evaluation matrix charge is improving support vector machine. So initialize the model with SVM SBC, fitting the data to model prediction. His accuracy is 77%. Classification report of performance matrix of different sentiment of negative and neutral positive sentiment with a precision, recall, and upon score. Here a confusion matrix chart with a different diagonal matrix represented in two positive values. So here we can see that the yes in the evolution matrix charge improvement with accuracy of 77%, precision with 76%, recall with 73%, F1 score with 70. Classification matrix report. Classification matrices are used to evaluate the performance model by comparing the predicted level to the actual level. Accuracy can be useful in evaluating sentiment analysis model, particularly if the classes are balanced. So accuracy is very useful for performing classification modeling. So accuracy, the proportion of correctly predicted level out of the total number of samples, it is computed by TP plus TN upon TP plus TN plus FP plus FN, where TP equals to true positive, TN equals to true negative, FP equals to false positive, F1 equals to false negative. Here the accuracy score chart. So a stochastic gradient descent performing very well in the conv vectorization, and TF-ID vectorization logistic regression performing well with accuracy of 78%. So stochastic gradient descent with a conv vectorization accuracy of 80% and logistic regression using a TF-ID vectorization at 70%. Therefore, we decided that a stochastic gradient descent model using conv vectorization to deploy for future use. Explain the model which use and the feature importance using a model explanatory tool. The model that we have used is the stochastic gradient descent as the classifier, which is a linear classifier that uses such as gradient descent to optimization to update the model parameter. The conv vectorization technique work by counting the occurrence of each word in the text and data, then creating a document term matrix where each row represents a document and each column represents a word in the vocabulary. To understand the features important, we can use the permutation importance technique. What is the scikit-learn library? The permutation importance technique work by random permuting value of feature and observing the effect of model performance. So conclusion here. We applied different 8 models, namely logistic regression, decision tree, stochastic gradient descent, KNN, multinomial wise, binomial wise for both conv vectorization and TF-ID vectorization. We conclude that the machine learning generating the best result with the stochastic gradient descent with accuracy of 80.43%, followed by the logistic regression grid surgery at a TF-ID vectorizer model with accuracy of 78.86%. So in the future, we can repeat the analysis and compare it with the present sentiment analysis to gauge the impact of the initiative of the ground. So thank you, Alma Bata, for giving opportunity to present my project on coronavirus sentiment analysis. Thank you so much.